So hello everyone, today I am back with a new problem which is of easy type, and the question number is 35 and the search insert position. So given and sorted arrays. So here it is given that it is a sorted array. So what should click in our mind is that if it's given sorted array, then it should be a binary search problem. So let's dive into our problem. Let's scan through the question and let's see what's popping in our head. So given a sorted array of distinct position and a target value is given, and return the index if the target is found. So we need to return a index if the target is found, and if not, return the index where it could be if it were inserted in order. So we need to return the index if the target is found, or if not, if the index is not, if the target value is not there in the question, in the array, need to return where the index return the index where it would be if it were inserted in order. So we must write an algorithm with O of log n. So we know that in binary search the complexity is of big of log n, and we know that. So let's see the example number 1. So nums nums 1 3 1 3 5 6, the arrays is given and the target is 5. So it returns that the output is 2. So 1 0 1 2 3. So the middle element, so we need to return this. And let's see for the second example. This one is middle and this one is start and this one is end. So we know that in binary search the first element is start and the end element is end. So the target is 2. So 0 and 1 2 3. And let's see what is the middle. So for the middle we need to find start plus end by 2. So start is of 0 plus 3 by 2, which is 1. So this one is middle, this one is end, this one start. So it will be around here. So the target will be around 2. So it will be 1. So 1 2 3 5 6. This index we need to return. Just remember that we don't need to return or insert the value here. Okay, if we try to insert the value here, it will be index out of bound. So we just need to return the index where we need to, where it will be, where it will be. So yeah, and so let's see. So here it's given a sorted array, then we need to use binary search. So now let me explain what binary search is. Binary search. So the first thing in binary search what we need to see is that the arrays should be sorted. Sorry for the spelling mistake. Sorted. So yeah, so let's see example of 1 2 3 4 5 6 7. So yeah, this one is 0 1 2 3 4 5 6 index. So we know that in binary search there are 2 pointers. We'll consider 2 pointer. One is one is start and one is end. So we know that start will be at index 0 and end will be at the end, which will be, let's consider n minus 1. So what we know that, so we need to find the mid. We need to find the mid. So to find mid, what we need to do, start plus end by 2. Start plus end by 2. So here the end is 6. So we know that start is 0 plus 6 by 2, 3. So we know that mid is 4. So the condition for, there are 3 conditions for binary search. So case 1, if mid is equal, sorry, let's consider this array arr equal to, if array of element mid, if is equal to mid, is equal to target, then we will return mid. In this case, if the target, let's say the target is 4, and we know that if this middle element and this ARR of mid, this one is ARR of mid, and the target element we are finding here is 4. So if both are equal, then we'll return just simply mid. And if case 2, if ARR of mid is greater than target, okay, let's say see this example. If ARR of mid is 4 is, so let's take another example here, let's take 5. Okay, so if ARR of, no, let's take 3, ARR of mid is greater, okay, then will 3 is the suitable example for here. So 4 is greater than 3, so we will neglect this part. We'll just see here, because 4, so the 4 is greater than 3. So if we are finding if the target element is 3, then 3 must lie before 4, as this is the sorted arrays, this is the sorted array. So we'll be just neglecting this part and we'll just scan till the here. We are just shrinking the arrays. Okay, binary search nothing, just we are shrinking the arrays and we're just looking for here, we're looking for the targeted element. So here so the, let's consider, so we'll just neglect this part, and we'll just neglect this part. And how can we neglect this part? So to neglect this part, we'll just end will be mid minus 1. No, end will be mid, let me end will be simply, it will be nothing more than that. End will be mid minus 1. Here the end will be mid minus 1. End will be here and mid minus 1. And for case 3, if ARR of mid is less than target, then if let's say let's take the another example here. Okay, let's take here another example. Let's say the target is let's say the target is 6 and the mid here is 4. So 4 is less than 6.
So here we just need to neglect this part because we are finding 6. So 6 is greater than 4 as this is sorted array. So 6 will be lying after 4. So we just need to neglect this part. Why we should scan this part and search again in this part? So it will be start equal to mid plus 1. Here here the start pointer will be pointing here. So we just need to scan till the here. We just need to scan till here. Nothing more than that. These are the cases. These are the cases. We just need to code, right? We just need to implement. And again, let's see here. It has given. So these are the cases I discussed. And if not, return the index where it could be if it were inserted in order. Okay. For here, we are not returning -1. We are not returning -1. Why? -1 represent here is that the element is not in the array. So here what we need to do that is let's dry run. Once dry run. So let's take the example which I took previously. Not this one. Yeah, let's take. Okay, I'll create one example. Let me see. 1 3 5 6 ARR equal to target is 7. In the case where the element is not present, what should we return? We can't return -1 as I mentioned here. It just indicate that the element is not present. We just need to return where 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 is the possibility. Return the index where it could be. So we just need to return the element. So yeah, here. So here the condition was while in the binary search we know that start will always be less than or equal to end. This is the condition in the binary search. So yeah, so let's see. Here it will be start and here 0 1 2 3. So mid will be 0 plus 3 by 2 equal to 1. This will be mid. And we know that start is 0 and end is 3. So yeah, and we know mid is 1. Okay, so now let's dry run. So we know that mid is 3. Mid is 3. So 3 is less than 7. True. It is true. So we will be neglecting this part. So our shrinked array will be 5, 6. 5, 6. So the index are 2, 3. This will be start, this will be end. So let's find our. Here the start is updated to 2 and remains as 3, and mid will be, let's see, mid equal to 2 plus 3 by 2 equal to 2. This one will be mid. So mid will be 2. So let's see again. 5, 6. So 5, 6. So the element middle will be 5. 5 is less than 7. The targeted element is 7. So yeah, true. 5, 7. Yeah, this is true. 5 comma 7, and we will be neglecting this part, so the element remain here is just 6. So this is our start, this is our end, and this is our mid. So here the start is updated to 3 and end is updated to 3, and mid is also updated to 3. Okay, we know that previously mm, the condition for binary search is start is less than equal to end, so this time the loop will be running. So mid will be 6, and 6 is less than 7, true. 6 is less than 7, true. And again start will be updated to start is equal to mid plus 1. Mid here is 3 plus 1, 4. 4 end will be 3 and mid will be 3. So here the condition fails. So we know that in binary search this condition is the while loop condition. Start will always be less than or equal to end. So here let's see, here in this array, here start, here end. So after in this array we know that the answer must lie inside this. The answer will be lying inside this. No, right? So after this condition violates, we see that end is here and start is here. So even we can't find the answer here inside here. So we this must be certain that the answer must lie outside of this array. So yeah, so we must return start here, cause we know that here, let's see this example. Equal to start. What example I was taking here was where is that array? Yes, 1356. 1356. We know that end is here and the start is here. So this is representing 0, 1, 2, 3. This start is representing here the index 4. So if the element is not found here, then this might be in this place, in the start place. So we need to return start. We just need to return start simply. We are not inserting element here. If we need to insert element here, then this would be out of index, out of bound. We're just returning the index over here. We're just returning the index. So yeah, this one. So now I'll implement the code and the Leetcode and show you how it's done. Now I'm going to show you how to implement the logic which I explained you. So I'll be using Java to implement the logic for this search insert position. So yeah, let's start. So I'll start with the pointer start. So int start equal to 0, which will be pointing to the index 0, and end equal to nums dot length. So as it is starting with 0, so I'll be taking nums dot length minus 1. So if I'm not taking length minus 1, then it will be out of bound. So to prevent that, I'm going to use end equal to nums dot length minus 1. So we know that for binary search the condition will be start will be less than equal to end. Yeah, so now I'm going to find mid. So int mid equal to, so start plus n minus start by 2. So I previously discussed about the three cases and for the binary search. So the first one is if nums of mid is equal to target, then we'll simply return the mid. We know that if nums of mid equal to target will return mid. Answer is found. So yeah, RETO return mid. So the another case, else if, we know that else if nums of mid is greater than, if nums of mid greater than target, we know that end equal to mid plus 1. Simple. And else, sorry for the spelling mistake, ELSE, else. Yeah, else we know that start equal to mid plus 1. Yeah, now I'm going to simply return start. RETUN return start. I explained you previously why I'm going to return start. So let's run and see. Time limit XTLE. Oh, sorry, I made a mistake over here. -1. Sorry for that. Now let's run and see. Yeah, it's working. Let's submit and see. Yeah, it's working. So thank you for your time. Thank you for watching my video, and thank you for your patience. So comment down below where can I improve my video, and any suggestion you can give in the comment. And yeah, more content are coming in future, so stay tuned for that. And yeah, thank you for your patience and thank you for your time.